Hi, this is Mrs. Carnes, and we're going to talk about absolute value inequalities and how you go about solving them. Now, it just might be helpful for you before you watch this video to go back and watch the Solving Absolute Value Equations video. We had already talked about solving equations that involved absolute values, and the only thing that's going to be different today is that we're going to have inequalities instead of equations. Now remember, with inequalities, we have greater than, less than, is greater than or equal to, or is less than or equal to. And we also have a rule that says when we multiply or divide by a negative number, the inequality symbol must flip. And so you have to keep those things in mind whenever you see inequalities. Other than that, the steps are going to be absolutely the same as if it was equations that we were solving. Let's go ahead and begin. Here's an example that we actually used when we were dealing with equations, but this is an inequality. It says that the first step is to get the absolute value sign all by itself, to isolate it on that side of the inequality. And so we notice that we have this -2 that we'll have to get rid of, and we have this 4 that we'll have to get rid of to get the absolute value all by itself. Using your inverse operations, like you are very familiar with by now, you're going to add 2 to both sides. You get 4, absolute value of k plus 1 is strictly greater than 16. We have not flipped the inequality sign. To get rid of that 4 in front of the absolute value, we know that we must divide because we're going to use the inverse operation of multiplication. And therefore we end up with the absolute value of k plus 1 is greater than 4. Once again, notice the inequality did not flip directions because we did not multiply or divide by a negative. So step 1 is complete. We have isolated the absolute value sign. It is the only thing on the left-hand side of your inequality. Step 2 then is to write 2 inequalities this time. It was 2 equations when we were dealing with absolute value equations, and now it's 2 inequalities. The steps are almost the same, but there is one thing you need to watch for. The very first thing that you're going to do is you're going to drop the absolute value bars and write exactly what you see. You're going to have k plus 1 is greater than 4. We just took away the absolute value bars and we wrote the statement that we see. K plus 1 is greater than 4. The second inequality that you'll write, you will also drop those bars, k plus 1, but this time the inequality symbol will flip directions, so it will become a less than this time, and the 4 becomes the opposite, which is -4. The answer will become the opposite. So let's take a look at this step one more time before moving on. The very first equation that you're going to write is going to be to drop the bars and write exactly what you see. That is no different than equations. The second inequality that you're going to write, you're going to drop those bars that go around the absolute value bars there, and you're going to flip the inequality symbol and make the answer the opposite. And from there, you have written your 2 inequalities for step 2. In step 3 now, it's just to solve these inequalities like any normal inequality. And so let's go ahead and take a look at the first one. To get k by itself, using those inverse operations, we're going to get k is greater than 3. And using the inverse operations on this inequality, we're going to get k is less than -5. Remember, if we would have multiplied or divided by a negative at any point, those symbols would have flipped directions. But in this case, nothing happened, so we have the answers k is greater than 3 and k is less than -5. So you can have answers that are going to be greater than 3 or less than -5, and they will work in that inequality that we started off with. Now the last step is to check our solutions. And so we're going to check our solutions by plugging values back into the inequality that we started with to see if they make sense. We're going to first of all start with this side. K is greater than 3. So we're going to choose some value of k that is greater than 3 and see if it works in our equation. So let's go ahead and just choose 4 in this case so that we have a value to plug in for k. So what we'll do is we'll end up taking 4 and we'll plug it in for this k right here. When you start to simplify this, you will know that 4 plus 1 is 5. The absolute value of 5 is still 5. 5 times 4 is 20, and 20 minus 2 is 18. And the statement that you end with then is 18 is greater than 14. And so you have to ask yourself, is 18 greater than 14? And in this case, that is a true statement. So k is greater than 3 works for our inequality. So we have to do the same thing for k is less than negative 5. Now remember, to be less than a negative 5, we have to go further on our number line to the left. And so in this case, you could try something like negative 6 or negative 7 or negative 8, because those are the values that are going to be smaller or less than the negative 5. So let's choose negative 7 this time, just to make it a little different. So you're going to take negative 7, you're going to plug it in for that k value from the original inequality, and you're going to simplify. So what's in the absolute values first? Negative 7 plus 1 is negative 6. Absolute value of negative 6 is positive 6. Positive 6 times 4 is 24, and 24 minus 2 is 22. And you have to check, is 22 greater than 14? And yes, that works. So we know that k is also, or can also be, less than negative 5. So those are the two answers that you would have. K can be greater than 3, or k can be less than negative 5, and it will make the inequality that we started with correct. Excellent job. So now you should know how to solve absolute value equations and absolute value inequalities. I would remind you again that you can go back and watch both of those videos, the equations and the inequalities again. So feel free to do so if you need extra help.